Hi, my name is Hafsa, and the topic of our article is a very high resolution assessment and modeling of urban air quality. To start off, the study we are presenting focuses on the air pollution in the Bergen, Norway. Bergen is surrounded by the mountains, so the pollution easily gets trapped, especially like on the calm or the cold days. So that makes the air quality a big issue there. And to understand like how pollution actually moves through the city, the researchers use a very detailed computer model that works at like a 10-meter resolution. This level of like detail lets us see exactly where the pollution builds up and why certain neighborhoods gets affected more than the others. Overall, the goal of the study was to like help the city make better decision for like improving air quality and protecting the public health. And the main purpose of the study was to like understand how pollutants like NO2 and PM2.5 spread across the cities. And to do this, researchers used a model called PALM, like which was like very good at showing like how wind and turbulence like behave around the buildings and the mountains. Also they did not like look at just one situation. They tested like 27 different weather scenarios, changing like the wind speed and the wind direction, and also the temperature. And they it also like included the emission from the cars, ships, and also the fireplaces from the homes. So like by comparing all these combination, the study like showed when pollution gets worse and why it happens, and what sources are causing like these all issues. And in this slide, like I'm gonna like explain the model they used, which is called palm large eddy simulation model. So palm is basically a very like advanced 3D simulation which shows like how air moves on like the small scale, such as like between the buildings, around the mountains, and also through the narrow streets. It uses like tiny 10-meter grid cells, so it captures like the details that most models like miss. Um, and it also like includes like the real temperature profiles and uses a method to keep the simulated atmosphere realistic. So because it can show like the turbulence and the small wind patterns, so like palm is like extremely accurate for like the complicated landscapes, such as like the Bergen County, Norway, in Norway. So this is why like it's like very perfect model for like studying urban air pollution.
So the key findings that we found in the article were that there was strong temperature inversions in the lower 100 meters, which traps pollutants. The weak wind leads to poor ventilation in the valley. Pollution flows down valley toward forward due to the channeling. There were NO2 peaks that were near the major traffic corridors, and the PM2.5 accumulates in populated areas with many fireplaces. Road traffic was the dominant NO2 contributor across the city. We found out that the fireplaces again were the largest PM2.5 source during the winter. The ships emit heavily, but they contribute less at street level due to the emission height. There were up to 16 ships, which emit more than total NO2 than all cars, but the impact is localized. The PM2.5 pattern is widespread due to numerous fireplaces. We could say that the why was answered. The LES modeling revealed fine-scale behavior that was not normally captured by traditional methods. It identified major sources and vulnerable neighborhoods, and it showed that the policy should prioritize road traffic and residential heating reductions. So how does this connect to our main topic? The study underscores the need for reduced dependence on fossil fuel vehicles and wood burning. The combustion-based energy use directly worsens air quality, and it supports transitions to electrified transport and cleaner heating systems. The high-resolution modeling guides sustainable urban energy planning. So all in all, the high-resolution LES method provides a detailed and realistic pollution maps. The topography strongly controls pollutant pathways. Small-scale features like lakes reduce concentration via ventilation. Ships have limited ground-level impact except in certain scenarios. And the model supports improved policy decisions for emission control. Thank you all for listening to our presentation. Do you guys have any questions?